Hi, welcome to the presentation of the paper titled Situation Awareness via Information Overing in Post-Disaster Communication. I'm Gaetano Manzo, and today I present you the work in collaboration with the University of Applied Sciences Western Switzerland, University of Bern, and University of Salerno. So, let's a bit consider post-disaster situation, okay? Whenever it happens, a flooding, an earthquake, or terrorist attack, or particular accident in crowded area, or a wildfire, or other kind of disaster. All these disasters have in common that they can jeopardize the network cellular infrastructure. And for example, if you take an earthquake, can actually break the cellular infrastructure. If we take a crowded area, we all experience delay during New Year's Eve or if we go to a festival. And sometimes actually operator they turn off this cellular infrastructure for avoiding any further damage. So in this case, the communication between people requiring help and people actually that can provide support, it's broken, okay? And in this situation, opportunistic communication actually can support this miss of communication. Opportunistic communication are all kind of peer-to-peer communication. And we will discover further in this presentation how we can actually use them to support the communication between people requiring assistance and people providing assistance. So let me be clear here. When a disaster happens, there are ad hoc solutions, okay? The problem that these ad hoc solutions sometimes are really hard to deploy. But we have a smartphone with us. Let's find out that. I would like to introduce this with an example. I live next to the mountain and I go to ski sometimes. Whenever I go to ski, I use this device. It's called DVA. It's a detector of victim avalanche. This allows you, in case you crash on avalanche, to be found from other people. Okay, so you can activate this, put in your pocket, actually on your chest, and if something bad happens, people can find you with this device. The problem of this device is that it's not so much popular. There are many people not using this device, many tourists that actually go to ski 1 or twice per year and they don't want to approach that. This is a not daily use device. It's not a device that you use every day, so it's a bit hard to consider as a daily use device. And it requires training. So you need to be trained in order to use this device, because it's easy to activate in case you crash, but you need the training to find the person, okay? And this device can be quite expensive. You can rent it, but if you want to purchase, it can be quite expensive. Instead, we have a smartphone, okay, which it can be a support, not a replacement for a dock device. Smartphones are popular. We use every day. We can consider ourselves experts. We don't need a training for that. And they can be affordable, okay? So let's find out how we can use a smartphone to support ad hoc solution. I introduce you Floater. Floater is a mobile application that implements opportunistic communication, and Floater is aware of the context and provide context-aware service. Let's see how. If, for example, I am a victim and I'm stuck in my house with a broken leg, I can send this message. And this message will be received from the people around me. And people around me is based on the wireless technology that I'm using. We will see which kind of wireless technology we can use. And people are receiving this message. Actually, they have quite a lot of information. They know the message. They know what kind of message we will see later that we can send a different kind of message with the Floater app. We can see the distance between people receiving this message and the victim. we can actually check how long this message has been sent. Okay, so by clicking here on map, we can actually see also the person, where is it. Floater implements floating content. Floating content is an opportunistic communication paradigm, and it's infrastructureless, so it does require the infrastructure. Floating content use a geographical area, and thanks to this geographical area is able to limit the exchange of the message within it. So in this geographical area, the gray area, we have two kinds of user. A first user that is actually the victim and would like to spread this message. The second user is the user that finds out himself in this area and would like to provide assistance. In the moment that the user goes in contact with the user that want to send this message, the message is sent, and so on with all the peers inside this area. Okay, this is what we call opportunistic communication. Again, the message exchange, it happens only inside the anchor zone. And if you are curious how this anchor zone is shaped, the dimension, all how to model this anchor zone, you can find out this work. We have analytical and machine learning approaches that actually model this anchor zone. To give you any hint, it's really based on the application that you are actually run on it, and it's also based on the trade-off between performance and the energy. Thanks to floating content, Floater is able to send different kind of message. So for sure, what we saw, it was a victim message in case a user requires an assistance. You can also provide dangerous spot. So you can actually say, in this case, this path is not saved, for example, or you are actually witnessing an accident. You can actually highlight a resource spot, or you can actually localize health point. Okay, this is just a kind of four kind of message that you can send, and you can see them on the map: victim, resource, health point, and danger spot. Okay, and this what we saw on the map. It's the anchor zone. This is a view of the floating content of the Floater app and the floating content actually application. So as I mentioned, Floater use different wireless interfaces, and it does that implementing Google Nearby. Google Nearby enable Floater to communicate without using a data connection, and it try always to keep balance between the performance of Floater and the energy consumption, where the energy consumption is actually the battery of our smartphone, and the performance is based on the how many people receive this the message that you would like to spread around. You start to use the Wi-Fi, so remember that we use Floater as a support and not as a replacement. In case there is no Wi-Fi, you try to use Wi-Fi direct, ultrasound, Bluetooth. And if you would like to know more about Floater, please have a look to this link. City where I live, we have autonomous vehicles, autonomous buses actually. You can see here in the picture. Embedded, they have the Floater app, and thanks to that, they can actually provide warning accident, traffic jam, or other kind of infotainment information messages, and they can actually communicate between vehicles, or between vehicles and pedestrian, or between vehicles infrastructure. Okay. Another way to use Floater is to do federated learning. Federated learning means to share the dataset and the model between peers in order to enhance the training of the model and its accuracy. In this case, we are actually see an indoor localization where each of the user is learning part of the map. And the moment that they meet each other, they share what they learn. In this way, the user has the total knowledge, the overall knowledge of the map without actually exploring all the map. So in Floater, actually, we implement a different system to avoid fake news or inaccurate information dissemination. User actually can provide the feedback to the message in order to enhance message reliability. There is an anti-spam, so it's not possible to spam advertising messages. You can actually rate the user to check his behavior. And we have also an active guide, especially for disaster victim messages. Okay, the user interface become much more friendly. It's much more easier. Whereas in the case of an advertising message, you can have a timer to confirm the message that you want to send. In case of a victim message, the priority to send the message, so you don't need a double confirmation and so on. You can check out all these features in the paper if you wish. I hope you would like to try Floater. You can find this link or by using your smartphone and open the camera, scan this QR code. So we present the opportunistic communication, and we see how they play a key role in, especially in the aftermath of a disaster. We try to use our smartphone as support for ad hoc system, and in order to do so, we implement a Floater app. Floater app is made with floating content, which is an opportunistic communication model, allows you to restrict the information sharing and to provide the message to the people around you. And we use Google Nearby API in order to improve the performance using different wireless interfaces and to provide a good balance between performance and energy consumption. As future work, we would like to continue the federated learning part, and we are actually working on an hackathon to implement a solution for this particular situation of the virus COVID-19. And in particular, we can use a Floater every time that we go out for going to the supermarket and to avoid not respecting the distance between people. For example, when you are in the queue of a supermarket or somewhere else. So I'm Gaetano Manzo from University of Bern and HES, and thank you for your time.